Hello everyone, my name is Matthew and today I'll be showing you how you can create your own interactive story-based game using Python. To do this, you have to know a bit about Python, which includes if and else statements, while loops, and a bit about classes and dictionaries. About me, so I'm a grade 8 student from Singapore, and I've created a few projects, including this ultrasonic scanning device to encourage recycling in communities, and I've also created this navigation app, which helps new students find their classroom if they're new to the school. So today, you'll be creating your own choose your own adventure game. This will be done using Python, and it's almost similar to a choose your own adventure book, in which a player there's stages of a game that players go through, and they can choose an action at every stage of the game that maybe helps them or weakens them, or maybe kills them or something. But first, you need to download your IDE, and I've put four great examples down here. Uh, Replit, however, is an online ID and does not require any downloads. The rest of the three are local, and you will be able to use them uh, on your computer and probably without internet connection. But first, what we need to do is talk about flowcharts. And a flowchart is a diagram that represents a process in a sequential order. So for example, on the right, here is a simple flowchart that goes through a sequence of steps, probably in your everyday life. So for example, we have the start, which is where the lamp does not work. And first we need to check that, you check that the lamp is plugged in. And then from there, you can see that there are two branches going from there. So either if it's not plugged in, then you have to plug it in. And if it is plugged in, then you go on to the next step, which is if you check if the bulb is burned out. Then if it is, you replace the bulb. And finally, if has not burnt out, then you need to repair the lamp. So as you can see, these branches are basically the choices that the player can make, and basically all the diamond shape yellow objects here in this example are the choices that the player can make on whether it'll help them or maybe not so much. Now we also need to talk about selection versus repetition. They're both very similar things, but selection is more of an if than else statement, whereas repetition is more of a while statement. So for selection, maybe you'll be asking a player if they want to do this, like maybe raise their hand, or if they want to instead lift their feet or something. But repetition is slightly different. And even though there is still a condition, repetition will be the process will be repeated continuously until something is satisfied. So for example, if we look at the example on the right, at this point here, we have condition S, and this is selection because there is no loop back to S, as you can see. So there's only two branches going from S and nothing else. However, it says if the player chose a yes on the condition S, and if you look at A, you can tell that, however, this is repetition because A will be a loop here, and specifically at this condition R, there will be a condition, and if the output is no, then it will keep on repeating this until the output is yes. And similarly, as you can see here, in D and R, we also have another repetition loop, where however small s here is a selection. And also here R is the repetition here. So now we can get started and start coding. So as you can see, today I'm using Visual Studio Code. This is made by Microsoft. And here I've created a very simple code on an example of maybe a program that will allow the user to enter a choice and also provide them story. So for example, here at the start we have our print statement that gives a bit of context to the user. So in this example, the user is stuck in a prison and they have to escape. So there's a bed and a toilet and a small window, and then it gives the user four choices on what they can do. this is all in one statement, and you can, and I put the triple quotation marks here so that you can put your string. This is a string, so you can put the story across multiple lines. Now next, after that, what we have is an input statement, which is assigned to a variable choice, and this allows the user to enter input and to choose basically which choice that they want to do, if they want to break the guard or feign a medical emergency, etc. And finally, after that, I have an if, elif, and else statements. And this is basically similar to that example with the lamps. So you can think of it as the if and then the elif and then the else instead of the if. Yeah, and so here if I run this code, for example, um, you can see that the print statement gets printed out, and then it gives you this context, and then it will ask you to enter an input, and you can choose something like a medical emergency. Then if I put in two, for example, and click enter, it will um, it will show a prompt, and yeah, and then maybe if we continue this code, something new would happen. Right, and then say I put something like invalid, say I put an invalid input or enter something random, the program will tell me that there is an invalid input. So again, this is a simple example of a selection and in terms of the flowchart, and currently there is no repetition yet. So continuing on to the next example. Here I have a more intermediate example, and here there are two techniques I've used in this program. So first of all, we have our repetition here in the while loop, and then there's also a thing I've used called abstraction, which is basically what you're doing is removing the slightly unnecessary details and putting them in a function earlier before so that when someone reads through your code, or even if you need to read through your code, then you do not need to, it will make things a bit easier to understand. So for example, and later on, maybe if you get to multiple choices, instead of having to print out like all the possible choices and all the time and like do something like choice equals input and put in the statement like what will you do, and then you have to get choice, and then you have to maybe check like if, for example, if it's a valid input by using this. You can all put that in a function here. So I call this function ask. And basically what it does is it takes in a list, so a Python list of four possible choices. There's a code here to print out all the four possible choices, get the input, and the return value will be the choice that the person has selected. And so it makes it a bit easier, and you can do all this in one line, and rather than having to use multiple lines. Abstraction can also be used even if you're only using a function once. You should probably still use abstraction if there are many lines and it's a big it's a very big sub chunk of your program, and I'll show you what that maybe looks like later. But for now, the other thing I like to talk about is the repetition here. So here it's this repetition here is also more specifically an input validation, and it's basically checking that the input that users entered is correct, and it will keep on checking that until a valid input is given, and then it will return the correct value and allow the user to continue. So for example, if I run this code, sorry, if I run this code. It's the same program, and there is again that prompt, that story that you're stuck in a prison, you have to escape. What are you going to do? Now we have four options here again, and say for example now that I want to create an invalid input, I can put something like 88, and it will say an invalid input because here we have first of all um, we've got two options here, and we've got first of all we're checking if choice is a digit, and we're also checking if it's in the range of one to the length of the choices itself inclusive. So if we were to put this in a flowchart, it would look something like this. So in the prison example, we have to start with the code. So draw the start here, and basically what will happen afterwards is again we have um, so I'll just label and show the flow of the algorithm with the arrow, and basically what will happen is you have the output here in which the player is given the backstory of what's happened. So there will be an output statement here, so you'll output stuff about so that will be the print statement at the beginning, which will say you're in prison and what here are the things that this is what you can see. Then David will ask them for input, which is asking them what would you like to do, and so you'll have an input here with the choice. No, sorry for the bad drawing, but basically then we'll ask them for input, and now here comes the important part in which we need to check, um, in which we need to check if that input is valid. So here we're going to check. So we're going to add like a if, and then maybe we can write a choice is valid or not. And then afterwards, what we have is if it is valid, then we're going to continue down. But if it is not valid, what we're going to do is, sorry, we're going to continue and bring this back all the way back to the input. So this way and this way. And basically what that does is it's a continuous cycle. If, of course, the youth decides to always enter something invalid. And eventually, if they do enter something valid, they will continue. And then what we'll do is we'll basically add a check. And if we write like choice, if say is th equal to 1, then if that's the case, then they'll do something, then they'll check again if the choice is equal to the 2 or something, and here, and etc. And this here, this part of the choice here, and this is all the if and else, the if, elif, and else statements. And so even though there are really, in terms of the flowchart, there really isn't much difference between the if and elif statements here. There is a slight difference on the Python, which is not much, but it's still a bit substantial. So back with our code here, what we can see is can continue and say I'll continue with this and say that we actually do pick something correct. Then we can add a list of of if conditions again, so you can check if it's 1, and then if it is 1, so that's primary card. You can write something like you try, like you fail. And then maybe you can write another condition if if the person has picked the second choice. And then here we can say so that's the emergency. You can say the card brushes over. And then maybe if you try and examine the cell, alright, then you can find something like so for example, you find a key, and if the choice is so you can use the elif, or you can even use the else statement. Since we have already validated the input here and checked that is the correct input, then we can write something like you can print like you don't even have a key or something. And yeah, make sure that when you're writing your code, you're considering the path that the player takes. So, for example, they haven't examined the cell yet, so they will not find a key. So even if you say that they have a key, if their choice is three, they won't if their choice is four. So, however, now maybe what you want to do is after this, you want to have maybe the correct thing to do is first you need to examine the cell, and then you need to pick the lock. And so then what you happen is you have to ask the same question twice. And so then of course it's also important. Then what we can do is we can add another while loop outside of course our validation here. So just remember that they're different things. And we can add another while loop and then put all this inside. And for example, say that, and then maybe like we can add, for example, a variable. Like we can put, say, key. Let the variable be key equals false, so it's a boolean, and basically all it's doing is just checking if the player has a key. So if they find a key, right, we say they have a key, and here we have the check if key, so we're checking if they have a key. So if they have a key, then you can break out of the while loop, that is. And if they do not have a key, you can print you don't have a key, for example, and just continue. So what this will look like basically is like this. And so for example, say we want to break the guard, you try but you fail and that doesn't work. You try and pick an emergency, again nothing happens. Now say you try and pick the lock, well, you don't have keys, so nothing happens because key is false. And the last thing you can do is examine the cell, so you find the key, and then you pick the lock. And then it will break out to here, and then here we can continue and do something. So again, then we can continue, and we can do another choice. So like you say, choice equal, well, first of all, we have to have a print statement. So you can write, you start running in one direction and reach a fork. What will you do? And then you can have a choice with like, so again, I'm going to use this ask function at the top of abstraction, and I'm just going to say, maybe you can do something like left, and then you can do something like right. And it's important to note that the input of ask is uh, a list, right? So it's put in a list so that you can iterate through the thing in the for loop. And so say you examine the cell and pick the lock, start running, and then you have two choices, and then say choose something like three that's invalid, and then you choose left, and then it'll just continue on. Alright, and so yeah, so this is another example. I'm a bit more complex with abstraction. Finally, I'd like to go into the last example we have, and here basically what we're going to do is we're going to use a class. Now this class is called scene, and basically what classes do is it's a special collection of things like functions, and that basically you can use, and also stores variables that you can use with this class. So basically, for this class we've called it scene. So basically, every single class that uses the scene example. So that's what it does is basically what we have is our init function so that when the scene class is created, that this is for each individual scene. Uh, we have the description, the choices, and basically the next scene, which is basically the branches. So then we have here I've set next to equal to an empty list so that we don't exactly need to put that in if there is no branch after this. And I've also created another function called run inside it, and basically what it does is it prints out it basically runs the thing. It's almost similar to the ask function in our previous example. And then it's the same thing, so it's a bit different. So print out description, and this is basically this description. You're in a prison cell. What to do? Then while true, it will go through every single choice and print it. This is of course using the enumerate function, which puts the index and the value, both of them, and it will just print it using f string, and then the choice will you have a choice, and then it will check if it's a digit and if it's valid. Then if it's not, it will say it's an invalid input. So after this, you can continue like maybe putting options options, and then you can go through like basically the possible branches. And so And yeah, and this basically what this scene does is it helps standardize things so that so that you can create basically easily readable code, and so that's a bit easier. Now what I've done here is I've put this scenes basically dictionary, and what it's doing is it's initializing the key start, which is basically just starting a scene. And so as you can see, you have the description here, and you also have the options that you can do, which is press the guard, in an emergency, examine the cell, or pick the lock. And then what I've done is I've set the next values, so basically the paths of it, to say I'm going to call them branch 1 and branch 2, and then only then will we run the function in which it will ask the user for an input. And it's important that you make sure that you can probably try to set these things, these branches to maybe use strings instead of linking the actual scene in there. Because if you do the actual scene in there, what you're going to end up is you're going to have to create individual scenes. So like create a new scene inside that you have this, in which it's just going to keep on getting longer and longer, and it will also make it really hard to read. So make sure you don't do that. If you're using other languages like maybe C++ or Java or JavaScript, maybe you can try considering a pointer. That will be a bit easier, so yeah, pointer to the next scene. But for Python, it's a bit harder to implement, so I just use the string. And so if I run this code, apparently what it does is, again, the same thing, and then it'll ask you to pick an option. And I can click something, and then so right now I haven't done any class yet, so I'm going to do right now. And so after this, basically the key is to making sure basically the key is to making sure that to standardize everything. So right, so the problem is trying to standardize everything, but the problem is that certain cases have certain things, and maybe you don't maybe like things are different, and maybe once like maybe there's only like two options, and if you choose both of them, if you choose maybe you choose the one of them, you die, and the other one you live. And of course, not all the choices are the same. And as such, we need to create a separate set of values, basically another array to basically store what we're going to do after this. So I'm going to create a new list here. So I'm going to call it so we can call it like path or here and yeah. So basically, after choice is taken, basically we can what we can do is we can maybe let pass be another list. We can so we can maybe can continue contain statements in here. So we can do things like we'll put a for statements in here uh like um say I don't know say that fails. So just remember that the statement is corresponding to Barton regard, right? Because they have the same index, 0. Um, Then we can say in an emergency, which we can use right like that fails too, and then we can add and basically we can add for basically we can add for responses, and after that we can print pause choice. Make sure it's self dot pause, right? Because right pause because remember we're using the class. Make sure I initialize that too. So self dot pause equal path. And so we're basically what we're doing is we're putting path as part of the scene itself, right? So then we're gonna print self dot path of choice. Right, so now if we do the same thing, I say pick the lock. Right, yeah, and also make sure that you convert choice to an integer, right? Because remember the default output for input is for the input command is a string, so we need to convert that to an int, which is why more so important that we need to make sure that we include this thing choice dot is digit, because otherwise again the int commands are going to fail if it's not a digit, which would be disastrous. The worst thing that could happen to you is seeing those Python errors when someone's trying to play your game. And you try and make sure that you reduce those errors as much as possible. So here again, right, and also make sure that you subtract 1 from your index, because remember the choices that I put here are 1 index. However, Python uses a 0 index kind of system, right? So if you pick the lock, you could say you pick the lock, and of course it will print out that thing. So after we have kind of printed out the message, what we'll do is we can call the next, we can basically call the next scene, and maybe what we can do is do the scene. We can basically do scenes of we're using self.next here, and scenes of self.next, and then remember because that's a list. What we'll do is we'll put the choice in here. Right, so self dot next of choice is basically the branch one or branch two or whatever we want. So we have the scenes of say branch one, and then we of that. So then we can do is dot run, and yeah, and so then if say we create like the next scene or scenes of branch. But yeah, so and also so I can get the branch. I'm actually going to call this escape. Um, just because that is the branch we escape from the cell. So we've got cell escape. And then again, we can put a description here. So you start running, uh, do something, and then what you have, I don't know, two options. You can say that like you reach a fork, then you can either turn left or turn right. I remember to put this in the list, of course, and then after that, let's just say that if you turn right, you win, and so you turn left and turn right, and then say you turn left, and you say something like you get arrested, and I remember it's a different list too. So you get arrested or maybe you get caught, and then if you turn right, you say you escape. Congratulations. And what we can do is basically since so if you actually remember what the start scene was, we have four cases. You have bribe the guard, feign an emergency, examine the cell, or pick the lock. However, remember that the first two fails and only the last two work. Um, because the what we do is actually only the third one actually, as a matter of fact, brings you to the next place. And so remember what I did in the intermediate code is I put a whole while loop around the entire like kind of asking thing, ask function. Remember, so here I can do something similar, and I can I can do another while loop around that if you want, if I wanted to, but I'm just gonna make this a bit simpler and just I'm just gonna say that if you examine this, you and you find a way out. So I'm just gonna change this to that feels. Okay, so now I'm just going to use this case instead, and actually, alright. So then we have um we've got the next branch. And so remember, since the next branch is a list, remember it's going to be copying that index and it's going to be placing it, it's going to be accessing that index from the next. So for example, if our choice is 2 to feign an emergency, um, what it's going to do is it's going to break out and it's going to call option 2, which is actually index 1, which is actually branch 2. So I should probably be making this four options. You can do that like with four branches, or because or if you want, you can also use the dictionary. And here, since what I actually want to do is was actually what I want to do is actually to make the user, like basically in our previous code, what we want to do is make the user keep on going through this thing until they pick three. What I'm going to do is actually just use a dictionary instead. But first of all, let's change the run code so that it has repetition in there. And remember, there's a very big difference between repetition and invalidation. Even though they're both repetition, if you want to implement, something like actually like true repetition in your code, where the player is truly kind of repeating and like doing stuff. Remember that this is this for loop here, so this is the actual like player repeating themselves. And remember that this one is just input validation. It's got nothing to do with the code, nothing to do with the game except just making sure that things work. So the player repeating themselves, I'm gonna put that here, and these are just comments. And what I'm just gonna do is all this happens here. So you're going to print again. We're going to print that message because we still want to print that message. But instead of running that next scene here, it's just gonna continue. I'm just gonna put this unindent this, and if choice equals 3, just break. Remember, a break, this is only breaking out to this loop here, so actually here, it's only breaking out, right? Remember, so the while loop is from line 11 to 22, and then it's just going to break out onto line 23. So then, yeah, then that's about it. So, for this, after that, what we just need to do is just run the next scene, and I'm actually, and as I said, I'm just going to use a dictionary because sometimes some choices just don't have an next branch, so, uh, you can make this, maybe, use a dictionary, so, remember that, we have the key here, and then we have the value, which is the next branch. I'm going to just call it cell escape, right? Because it's this thing here. And so basically, then so this is just what's going to happen. And so what it's going to do again is run the scene, right? It's going to put the description, and then it's going to make the player keep on repeating themselves until they pick option 3, which is to examine the cell and realize that they can run out or something. You can make this more complicated if you like, and that's it for this part. And then after that, so again, this is the input validation. All this is not important. In fact, if I wanted, I can actually put this into that ask function here. So remember how I created this remember I created this ask function? You can actually just also you can abstract it you can abstract that function out, but for the sake of time I'm just gonna leave that I'm gonna leave the validation in here, and then it's going to print out the pause, and then if it's 3, it's going to break, and it's going to run the next scene. However, there is one issue, and is that scene is being used by multiple, and is being used multiple times for multiple scenes. So not always do you want, you don't always, basically, not always is the correct option going to be option 3, and if you set it to option 3 all the time, people are going to start to realize. So, what we do is, remember we have to we're just going to create one last list, which is the correct, I'm going to call it correct, which is the correct answers, and self.correct equals correct. And what we're just going to do here is, instead of checking if the choice is equal to 3, we can set check if choice is equal to, is in self.correct. So correct is going to be basically an array of correct all choices. So let's say we can go, correct choices are 2, 4, 6. Or maybe not correct, but maybe a better way of saying it would be the ones that don't kill you and make you lose there and then. That would maybe be a better way of saying it. And if the choice is in self.correct, then we're just going to So we're not going to break out. Sorry. We're going to run the next scene. Sorry. And yeah, no, sorry. We are going to break out. Sorry. We are going to break out. Right. Yeah. Yeah. We are going to break out. So because remember actually I mean you can what I can do is either you can break out and then call scenes the next run, or you can even just put it inside. Yeah. So both options are completely fine. Um. Because remember, if it runs the next scene, then nothing's gonna happen. It's gonna run the next scene, and after it runs the next scene, actually, after it runs the next scene, if you even get to line 24, that means either the player has died or they've won. And so in that case, the best thing to do is either, if you get to line 24, you can just quit something. So what quit does is so yeah, I'm using the Python terminal here. But if you do something like quit, what it does is it quits the entire program, or in this case here, it just goes back to my terminal. And so yeah, so that's the code here. Um, so we'll run the next scene. Even though you are running the next scene inside of a function itself, it make it seem a lot like recursion. It's really not that bad, and if you want, you can always change your code to move the run function to call the next function outside. You know, you can always return the correct choice. You can always do that if you want. And but for now, I'm just gonna put that there. Right. So we need to what we need to do is we need to next is right, I'm just gonna set correct to equal to let me do this here. I'm gonna set scenes star dot correct. Actually, no, sorry, you have to put in here. Uh, correct is equal to So I'm good. The correct option is three. Make sure that you do still put it in the list, even if there's only one value. It's still important to put it in the list because otherwise, this code is just not going to run. And remember, we're trying to generalize all of this so that the scenes are all the same. And yeah, so just make sure that it's still a list. Uh, correct is equal to so the correct option is to say turn right. So we're just gonna make it uh equal to two because there's only one correct option. And just remember, there's one thing that remember our choices are one index, so they start from one, two, three, four. However, the paths or anything else or all the lists are all zero index. So make sure that you get that distinction clear. So for example, in this here, choice and self-correct, the correct choice is three. It's choice three. Examine the self. However, make sure that you do not decrease choice. You do not do choice minus one because correct is a list, and we're checking if choice is in self.correct. Remember, choice is three, so we're checking if it is self.correct. So make sure you use three. However, if you are going to run the next step, right? So running scenes.self.next of choice.run. Right, remember that choice should be minus one because choice is in this case self.next is your index. So make sure that you get this distinction clear, and otherwise you're going to probably spend a bit of time debugging. And um, yeah, and so if you run the code here, Uh, right, yeah, probably won't. Right, so for the next, I'm actually just gonna remove this optional. I'm gonna make it compulsory. Just makes, yeah, maybe your life actually easier. So instead of doing the start on next is equal to that, I'm actually just gonna put in here. Just much easier. For this one here, yeah, since this is the last scene, what you can do is, I mean, you can, like, for the last scene, it's like, if you're creating the game, the last scene, you should probably try and make it a bit special. So probably don't use a normal class scene. Use maybe a special function or a special, create like that last thing yourself, make it unique, make it look nice. And if it is a long game, but here I'm just going to I'm just going to leave it blank. Uh, yeah, I'm just going to leave it blank. Sorry, I'm gonna, the correct option is to turn right, so I'm just going to call another thing called, like, win. And then what I'm actually probably just going to do is create, just a win function. I'm gonna default set to, false. Lost, sorry, lost variable, and this is just gonna just say it's the last scene, right? If it is, self.last equals last. And then what we can check here is if last, and you can print wow, you have won. Make sure to share the game or something. Um, right. So sorry, self.last that is. Yeah. So I mean, this is just a short thing that I'm doing for this. So for simplicity, I'm just setting this last variable that's going to say if it's the last scene or not, and if it is, then you can say yeah, year one. If it is not, then we're just going to run the next thing, and then after this, we're just going to quit. So what happens is if the choice is in self.correct, then and if it is an else, then you print while you have one. Make sure to share the game. If it else, otherwise, it is not the last scene. There's more to go. And we're just going to run the next scene, and for both cases, we're just going to quit. What we find also have to do is, continuing on, if you want to create another basically option that you die, um, you can create another thing called like self.incorrect. Basically, what it does is create like this, and so now there's three options. Either it's correct, right? Either you call it correct option or the option that's going to help you, that's going to bleed you to the next scene, that's going to let you gain progress, or either you just keep on repeating, that's the option that just makes you keep repeating, or you got the option that's so bad that like things go backwards and you like die or something. Like I don't know if you accidentally, if you escape in prison, you accidentally reveal yourself to the guards because you try to steal some food or something. That you can create that too, and what I'm just gonna do is right, sorry. Yeah, I'm just gonna create this scene. Uh, no, I actually don't need this. Uh, remember, what I'm gonna do is just set the last equals true, so this is the last scene. So when we run this code, uh, uh, when we run this code, again, we have this, options, and we pick a choice 3. And now we find that, in the cells that we have an error. And if you find out, well, it's not exactly an error, right? Like the program's still running, but the thing is, you realize it's the exact same choice. Like no matter what I do, if I choose three, which is the correct way, like you can see it's telling you it's the correct way, but it's still doing the same thing. It's still giving you the same option. And so now what we need to do is debugging, and there are a few ways that you can do this. If you have normal IDE and you just want to like debug normally, so what you would have to do is basically what you're trying to do is run through everything, right? So run through what the program is doing, and the best thing to do this is print out everything that is relevant, and saying what it is, right? So just that's like literally the best way to do things. Print out everything. That's important. So we can see that all of this is running properly. If you go back to the output, and if you look through the output, you can see that there is you can see that description is printed correctly. You can see that the choices are displayed correctly. So I'm just going to skip part of this, past this because that's correct. And but now we can see that this is correct. We can see that this is correct because this is printed out. And if we remember, this you find a way out statement is printed out and it's by this. It's by self.paths. This part. Right? So this is the process of almost an elimination of just running through the entire thing. Right? So it's an important skill to have and with time and practice eventually just gets better, your skills just get better. Alright, so we have that and then right, so the input validation is correct. This is correct. Sorry, this part is correct. Line 23 is correct. And now the only part that we have a problem with is line 24. Sorry. So now we get to line 24, and this is probably where the error is. Now, what we're looking at is if choice is in self correct, and if it's self.loss, you're gonna print while you have one, you make sure it's a game. Else it prints, it runs the next scene. Alright, so now there are a few possible errors. Let's go through all of them. Number one, the condition here, choice in self dot correct, is not working. Possible. Number two, uh, number two, and this is like basically that something here is not working. If we look at this case number two, we realize that this is definitely this self-loss is definitely a boolean, right? It's loss equals false, and I definitely put true here. Um, Loss equals false, by the way. This here is the default value, and right. So that's definitely there's nothing wrong with that. And then we look at this. There's nothing wrong with that. Definitely, it's a print statement. Uh, so we get down to two possible cases. Case one, this is wrong, and case two implies that this part is wrong, the else part, right? But I don't necessarily think that this part is wrong because there's no debugging error yet. And so it's actually easier to debug this too, so you probably just want to stick to doing the easier debugging first and the ones that seem more likely. And so the best way to do is just to print everything, right? So print choice, self dot correct. Alright, just print out everything. And by the way, that's Control C to keyboard interrupt and um, do the keyboard interrupt and stop the program. If I do examine the cell, you can see there's almost nothing wrong. You're right. Make sure it does that your print statements are clearly labeled, so you can put like choice and self dot correct here just to label what it is. Right? Obviously, nothing looks wrong. And however, there is just one tiny problem, and that is that actually, if you realize choice has not been encasted here, and so that is the problem, and that in choice is it's in choice and not just choice, right? So remember, for in keyword, um, the values have to be of the same type to work. So that is done, and if you can see, if we try again and put 3, now we find ourselves with another error, and that is this. Seeing to the next is wrong. So you can see that, right, make sure we do the earlier part first, because that will lead us to the next problem, and from there we can debug the next problem, which is that I shouldn't be using -1, so I'm going to make sure that that is indexed correctly, and if you run the code, um, You should also just make sure that all the typos don't have any typos too. So escape, right? Common error two, and if I run the code and finally you see you have fork, and then you want to turn right to win, and then it says you escape and congratulations. And make sure that when you're like kind of showing everyone your code, you remove all the non-important print statements. Um, yeah, so if you run it again, like you can see now it works. If you click the left, you get caught and you lose. Uh, you can again if you want, you can set another you can set another variable to make sure it quits if you lose, but see that works. And finally, I just have one last example to show you, and this is kind of maybe a more a example, and I've taken this from the Big Bang Theory. And anyone hasn't seen it before, it's the friendship algorithm that Sheldon Cooper creates. It's quite similar to a flowchart. In fact, it probably is a flowchart. And basically, what you've seen here is um, what I've done is I've done a few more things. Like, first of all, these are color escape codes. And what it does basically is that when you run the code, um, you can see that there will be a red color there, and you can use this if you need to highlight something important in Python. And I've also what I created is three functions: system, Cooper, and kite, which are the two people here. And yeah, this is just to standardize everything and make sure that when you have outputs, inputs are correct. Again, you have for this and then another function, and it's just to standardize everything to make sure that the input is all like correct and to make sure that it's all consistent, which is why we use abstraction sometimes. It might seem like you're overdoing it, but sometimes when you're printing stuff multiple times, you make sure that you can use something. We can use these things. I've also created the invalid input here, so again, it's the same thing. And invalid input. And so basically, what happens is this is the first message, that's the note. This is basically in this example, the user is nurturing Barry, which is the kind on the other side of the phone if you've watched The Big Bang Theory. So what you have is the stuff like it's going through, so it's placing a phone call. And so now what it's doing is this is almost a modified example of repetition, except that if it's repeated more than four times, it quits. Now this is easier to do than just having it run infinitely, so that you just doesn't like it seems a bit nicer. And so what I'm doing is I have a answer here, and this is the answer that Barry's gonna give out. Right, so this is the part that we're considering here. And so we ask for an input from the user, right? So we use this thing called IMP which gets an input, again, standardized input way. And if the answer is yes, you can print. If it's no, then I'm actually just following what the algorithm said, which is to basically algorithm said in the TV series, which is to uh, leave a message for Barry. You're playing Cooper for that. Again, I couldn't make this a completely one-player thing because it just doesn't like work out. So then, yeah, and then this is basically the excuse almost for having repeating basically that you're going to wait and then you're going to call again. I think if it does it more than three times, this is the addition I added, but if it calls it more than three times again, just gonna just I can delete. There's no point, like honestly. And yeah, so now, however, we're looking at this. If there is an invalid input, right? So if it's not yes or no, then it will say an invalid input. So for example, if I type something random, it will say invalid input. You could probably make that red too by adding this escape code. And what you do is you can add red plus that. So that's what you can do. So again, if you try that again, right now, sorry, wrong place. here. You can add that color escape code. You could also use this in a module I think called Colorama. If you want, but you can always just use that. So say I type something random as an invalid input. Make sure you're using escape codes that you also add the reset after that. So I will add the reset there, right? And so if I type something random, you see you put invalid input in red, makes it more readable, and then reset. And then say I say yes. Right, it doesn't recognize it, so I'll say yes with the capital letter. Then it goes on to the next section, right? So it goes on to the next section, and then this is an example where you're not just calling functions in within each other, and it's all nice and readable, and it's all, all unindented like this. Again, it's the same thing that I did for the next part, which is sorry, here, which is where do you like to share meal? So, print does you want to share meal, ask for an input, and then if so, they share meal, and if not, they don't. And the same thing, do you enjoy hot beverage? And at this point, if you watch the TV series, basically what's happening is Sheldon's trying to go through a list, and he's gradually getting his options reduced because the other guy, Barry, who the player's playing, just doesn't want to do them. If the answer is yes, then they share a meal together, it's all happy ending, but unfortunately, sometimes life doesn't work out like that, and so you continue on. So maybe Sheldon's asking for a hot beverage, and then you're going to right, sorry, you're going to Barry can give his answer. So again, it's tea, coffee, or coca. Um, alright, so Right, so then what you're gonna ask is asking for an input again for Barry, and if it's tea, coffee, or coca, then they share that together. You can also use the F string for this, but you created this a few years back, so I don't think F strings were there back then. Yeah, so otherwise, if it's a sad ending, then no, no, unfortunately, we're going to continue going on. And now finally, this has gotten to a quite complex part. Um, but basically what this is doing is, it's again another repetition. It's a bit hard, however, because it basically, Cooper also reputational activity, and then so Barry will say, oh, do I want to do this? And basically, then you're gonna have to break the fourth wall, and if Cooper wants if they're gonna ask if Cooper likes this activity. So again, making sure we use system and Cooper which are function to recreate. So if the answer is yes, then we break, and the answer is no, then we're just gonna keep on going. And if we've done it 5 times, which in this case it's 5 times because I'm copying the TV series, so it's five, then we're just gonna break and just gonna continue. Right, and then there's the invalid input if it's not yes or no answer. And now it's the same thing for the last thing, which is this is what option does Coop choose, and then this is remember input validation. Uh, so yeah, so you're printing out the four options, and then the input validation. And here remember that the validation and the repetition is almost really the same thing. So they're similar, but just make sure that you know the difference between when you're using validation and when you're using um, repetition, because they'll be very different, right? Validation is for making sure the user enters the correct code. Repetition is to make sure that is to continue doing this thing because it's part of the game itself. This is how you can the basics for stepping stone almost a starting block for creating a story-based interactive story-based game. And so there are some extensions that you can consider to store variables, for example, and which you can maybe you can have like a shop almost that you can use, right? So you can store a global variable, and so something like maybe you can give them coins, and maybe if they don't have enough coins, then they can't buy this thing, and then maybe it won't help them, right? So you can make it a bit more enjoyable. The second thing to do is you can implement the front end for the project. So right now all of this is text, but a lot of ways that you can use is either you can use JavaScript maybe, or to create the front end for the project to animate the thing, or you can use things like Pygame, which is a nice module to do this thing. Or if you want, you can even like just completely scratch using Python and change to other things. So, for example, if you're creating an iOS app, you can use Swift, which is a great also a high-end programming language, which allows it. Again, it's simple to use. It's Apple after all, so it's simple to use. When you can use that to create a game, and you can just completely forget about using Python. It's almost easier just to Swift. And then yeah, and or if you're using a website, creating a website, then of course you can use JavaScript. And then the things you can also do is like add color, which is so for from which is basically what I did back there with the friendship algorithm, which is adding the color escape codes. And so with that, I leave you with this project, this kind of idea that you can use, and if you this video is probably going to be posted on the YouTube channel of Hack Alpha X. I hope you enjoyed this. Feel free to comment with any questions you have, and I'll try to answer them myself for the next few days. And I hope you enjoyed this.